Okay, so yesterday we were talking about graphing a triangle that's, or finding the area of a triangle that's graphed on the coordinate grid. And remember, the whole idea is if you have it graphed, if you have a triangle that's graphed on the XY axis like this, for example, then the goal is to just completely enclose it with a rectangle and then just subtract triangles that you don't want to include in the area. And the area of that red triangle is really the area of the rectangle minus those 3 green triangles that are around it. Okay? Any questions about that? Okay. That was yesterday. Today, we're going to talk about one more method of finding the area of a triangle. Okay? So this is area of a triangle. Using something called Heron's formula. Okay, so Heron's formula is a way of calculating the area of a triangle without ever knowing what its height is. Okay, so here's what Heron's formula says. It says, given any triangle, with side lengths A, B, and C. So it could be any triangle. It doesn't have to be anything special. It doesn't have to be a cube. It doesn't have to be a right triangle. It doesn't have to be anything special at all. So it can be anything. Like this. This is like A, B, and C. The area is square root, big square root of S times S minus A times S minus B times S minus C, where S is A plus B plus C divided by 2, which is sometimes called, this is sometimes called the semi-perimeter of the triangle. Okay, so this is Heron's formula right here. Now, I'm not going to spend time talking about how that formula is what it is, because it involves a little bit more advanced trigonometry than we know at this point. Okay, but it works. This formula works. Just to kind of prove that it works, let's do our first example on one where we know how it should turn out. Okay. On a right triangle. So, for example, let's suppose we have a right triangle whose side lengths are 3, 4, 5. That's a Pythagorean triple. So we know this is a right triangle. And we know its area already. Like, we know that the area is 1/2 base times height, which would be 1/2 4 times 3. Which, of course, if if you had to calculate the area of this triangle, that's definitely the way you should do it. You shouldn't use Heron's formula. But I'm just showing you that it works. Okay? So this is really 6. Let's just make sure that when we use Heron's formula, we get 6 in this case. Okay? So the first thing we're going to do is we're going to calculate half the perimeter. Okay? We're going to calculate 3 plus 4 plus 5 divided by 2. So this is 12 divided by 2, which is 6. So that's the semi-perimeter. So then the area is the square root of 6 times 6 minus 3 times 6 minus 4 times 6 minus 5. You just take the semi-perimeter and you multiply and you subtract it from each of the sides. You subtract each of the sides from that and multiply those things together. That's it. So if I simplify this expression that's been the radical, I get 6 times 3 times 2 times 1. Well, 6 times 3 times 2 times 1 is 36. So this is the square root of 36, which is 6. Yay, we got the right answer. So hopefully you're convinced that it works. It definitely works for any type of triangle. It doesn't have to be a right triangle. It can be any type of triangle. So let's do one where it's not a right triangle. Just show you how it works. So if I have something like, suppose I have a triangle whose side lengths are 8, 9, and 5. Okay. The same process would work. I could say S, in this case, half the perimeter, would be 8 plus 9 plus 5 divided by 2. So 8 plus 9 is 17, plus 5 is 22, divided by 2 is 11. So the area then would be the square root of 11 times 11 minus 8 times 11 minus 9 times 11 minus 5. This is the square root of 11 times 11 minus 8, which is 3, times 11 minus 9, which is 2, times 11 minus 5, which is 6. So on my calculator, if I take 11 times 3 times 2 times 6, that's 396. And they'll tell you round it to the nearest whatever, and their integer or whatever. So if I take the square root of 396, calculator, 19.89. So if they said to the nearest tenth, this would be 19.9. And units are still the same. Like, so if this is like inches and inches and inches, then this is going to be square inches. Just like before. Okay, let's just do one more example. What if they said it's an equilateral triangle with side length 4, or something like that. So suppose it was an equilateral triangle with side length 4, and you're trying to calculate its area. And S in this case would be 4 plus 4 plus 4 divided by 2, which is 6. 12 divided by 2. So the area would be the square root of 6 times 6 minus 4 times 6 minus 4 times 6 minus 4. This is 6 times 2 times 2 times 2. 6 times 8, which is 48. So maybe they'll say, put this in simplest radical form. So if they wanted this answer in simplest radical form, what's the biggest perfect square that goes evenly into 48? What are you supposed to do if you can't think of it?
Wait, so the biggest square, that's 6?
6 is not a perfect square.
No, I have 36.
No,
No.
it has to divide evenly into it.
Oh, okay.
16. This is 16 times 3, right? So this is 16 times 3. So the answer would be 4 radical 3. And that's the area. So sometimes they might say, round your answer to the nearest tenth or hundredth or integer, or sometimes they might say, put your answer in simplest radical form, because these answers are all going to be square roots, right? So that's a possibility that they might ask you to put it in simplest radical form. But that's the process. First, figure out what half the perimeter is, add up the sides, divide by 2, and then just apply this formula. It's just the semi-perimeter times the difference between the semi-perimeter of each of the 3 sides. Okay? Any questions on that? Have you ever seen this formula before? Okay, good. All right, so the homework actually is a Delta math assignment again. And it's just called Heron's formula. So make sure that you're aware of like what's due on Monday. There's 2 Delta math assignments and there's 2 IXL assignments, as well as test corrections if you decide to do those. Okay? That's it.